This is the retake, the 5A retake practice video. The retest deadline is going to be February 22nd. That is next Friday, or this coming Friday. You should have the video, the Edpuzzle video completed by Wednesday night, the 20th at 11:59. So midnight, Wednesday night, you should have the Edpuzzle, this video completed so you can retake by Friday. Okay. These first ones, we are foiling this out, doing whatever operator is being asked of us, and getting it into standard form. So here I've got 2x times 3x squared. It's going to give me 6x cubed. 2x times 5 will be plus 10x. Then negative 1 times 3x squared minus 3x squared, negative 1 times 5 minus 5. Standard form, however, goes from highest degree to lowest degree. So standard form would be 6x cubed minus 3x squared plus 10x minus 5. The degree of this polynomial would be a third degree. And because it has 4 terms, that will be a polynomial. Anything more than 3 terms is a polynomial. In this second one, we are subtracting, so that when we subtract, we combine like terms. So I've got 11x cubed minus, I don't have any x cubes in that second one, so I just am left with 11x cubed. Next I have negative 8x minus negative 7x. When I subtract a negative, I add. So negative 8 plus 7 just gives me negative 1x. And then I have minus 2. I didn't have anything, a non-x over here that I'm subtracting 2 from, so this is just minus 2. And that is in standard form. So its degree, the highest exponent on that is a third degree. And it has 3 terms, making it a trinomial. Number 3, once again, I'm foiling this. So when I do these first ones, 3x squared times x squared is going to give me 3x, power of 4. 3x squared times negative 5 gives me minus 15x squared. Now I work with this 15. 15 times x squared is going to give me plus 15x squared. And 15 times negative 5 is going to give me negative 75. When I combine like terms, I have 3x power of 4, negative 15x squared plus 15x squared. Those offset each other, so I don't have any x squareds. And then minus 75. My degree, my highest exponent here is 4, so it's a 4th degree. And I only have 2 terms, making it a binomial. number 4, we are now adding these together. So I have 3 x cubes y power 5s. This is all one term, so I'm looking for other x cubed y power 5s, and here I have 9. So 3 of those plus 9 of those is going to give me 12 x cubed y 5. The next thing I have is 4x plus negative 4x, or 4x minus 4x, which cancels out, gives me 0. So this is what I'm left with. To get its degree, because this is all one term, I add those exponents together. So 5 plus 3 gives me 8. So this is an 8th degree. And because it's only one term, it's called a monomial. Monomial. Okay. In 5 and 6, we are looking at and describing characteristics of the graph. First, it asks if it is even or odd. You can tell which one it is based on how it ends. Both of these are going in the same direction. It doesn't matter if both of them are going down or if both of them are going up. If they go the same way, if both ends go the same way, that means my degree is even. To tell whether the leading coefficient is positive or negative, I look to the right side. On the right side, it's headed down. It's going down the further right I go. If it is headed down, that means my leading coefficient is a negative number. So my end behaviors, I have 2 end behaviors. There is as x approaches negative infinity, where does f of x or y go? And then there's as x approaches positive infinity, where does f of x or y go? The bottom one, as x approaches infinity, that I know based off of my leading coefficient. If that is positive, this would go to positive infinity. If it is negative, this goes to negative infinity. So because this is negative, this goes to negative infinity. Figuring out the other end behavior as x goes to negative infinity, that is based off of my degree. If it is even, both of these end behaviors need to be the same. If it is odd, these end behaviors would need to be opposite of each other. So since it is even, and I already know that this one goes to negative infinity, this one has to be the same, and it also needs to go to negative infinity. Part D says, what interval is the graph negative? A negative interval is when the graph is below the x-axis. So that is here, that it's below the x-axis, here, that it's below the x-axis, and here, that it's below the x-axis. I had to make that distinction right here at the point 4, 0, because 0 is not a negative y value, nor is it a positive value. So when it hits 0, I have to make a break. So this is negative from as far left as I can go, so from negative infinity, going to the x value of negative 3. And also, so I use the union, when I have an x value of 1 until an x value of 4. So 1 to 4. And also, because I have this other part here, from 4 all the way moving right to positive infinity. When it says it wants the equation of least degree, all that's saying is what would the equation be that would give you this graph, taking into account your multiplicities at your zeros and your leading coefficient. So I know that my leading coefficient needs to be negative. So I've got y equals, I know there needs to be a negative in front of everything. And then it is a matter of identifying what my zeros are, so what that factor would be. If I have a 0 at -3, that factor would be x plus 3. At this 0, it twists through, looking, if we were just looking at that, looking like a cubic function. That cubic function, that behavior of a twist, means it's a multiplicity of 3, so I have an exponent of 3. The next 0 that I have is at 1, so that factor would be x minus 1. Here, it crosses right through, just passes right through there, meaning that that is an exponent of 1. Since it's an exponent of 1, I don't have to write an exponent. The next 0 I have is at 4, meaning that factor is x minus 4. When it hits that point and bounces back in the same direction, or I have that behavior is being tangent, that means I have an exponent or a multiplicity of 2. So looking at number 6, because these go in opposite directions, my ends here, that tells me that my degree is going to be odd. To tell whether my leading coefficient was positive or negative, I look to the right side. It's going up as it goes right. Therefore, my leading coefficient would be positive. Writing out the in behavior, again, it's in 2 parts. So I have as x approaches negative infinity, where does f of x go? And as x approaches positive infinity, where does f of x, where does the function approach and head? So as it moves positive, as it moves right, my graph is going up to positive infinity. As it moves left, my graph is going down to negative infinity. Sim is asking, when is the graph positive? So that is wanting, when is it above the x-axis? So I'm above the x-axis from 0 to 1. But also this area here, going from 4 as I move further right to positive infinity. So I say union 4 to infinity. Once again, it wants the equation of least degree in factored form. So the equation for this function. Well, I know my leading coefficient is positive, so that means I don't have a negative that's going to be out in front. All I need to do is give what my zeros would be, and so what those factors are. I've got a 0 at -3, so that factor would be x plus 3. I have another 0 at 0, so that factor would just be x. I have another 0 at 1, so that factor would be x minus 1. I have another 0 at 4, making that factor x minus 4. Now I also need to include the multiplicities at these zeros. So on the factor x plus 3, here, it hits it and goes back in that same direction, meaning that that's going to be an exponent of 2, or a multiplicity of 2. When I'm at 0, it just goes right through, meaning that that's going to be an exponent of 1, a multiplicity of 1, so I don't need to write a 1. When I'm at 1, when I have the factor x minus 1, that also crosses right through, so it'll be an exponent of 1. And my last 0 is at 4, so my factor of x minus 4, and it twists through that, so that's going to be a power of 3. I'll give you that twist. The order you write these in doesn't matter. You could put the x in front of all of this. You could change the order of any of these. What matters is the exponents being on the correct factor. So that 3 needs to be on this factor of x minus 4. That 2 needs to be on this factor of x plus 3. And the other thing that is important is remembering if your leading coefficient is negative, to include the negative there. For 7, 8, and 9, we are now sketching based off of the equation that it gives us. So I need to identify where my zeros are. So I have a factor of x cubed, so that gives me a 0 at 0. A factor of x plus 4 gives me a 0 at negative 4. And a factor of x minus 2 gives me a 0 at positive 2. I do not have a negative leading coefficient. My leading coefficient is positive, which means on the right side, I know this is going to end going up. So I work drawing backwards. I know as it moves right, it's going up, and I know I have to come to this 0 at 2. When I get here, I'm looking at this multiplicity. That multiplicity of 3 tells me that it's got a twist through there. So it gets close and then kind of lingers and goes down. I know I got to make my way back up to get my 0 of 0. And so I look at that exponent, that multiplicity is also 3. So one more time, it needs to twist through that. So it gets close, stays there a little bit, and then carries on to the other side. And then I know I got to come back down to hit this last 0, and I look at that multiplicity. It doesn't have an exponent, so that's a multiplicity of 1, telling me that it's just going to pass right through. It's going to just cross through right there. So that's what that sketch is going to look like. Here it's the same process. I identify where my zeros are. So this factor of 3x, the 3 doesn't do anything. All I'm saying is if 3x equals 0, I divide both sides by 3, so x still equals 0. So I have a factor at 0, or a 0 at 0. I have x minus 4. That would give me a 0 at positive 4. I have x plus 2, which gives me a 0 at negative 2. This time, my leading coefficient is negative, which tells me as it goes right, it's going to head down. So now I know I got to get to this 0 of 4, so I look at that multiplicity. That exponent of 3 tells me that it's got a twist through there, so it gets close to it, lingers for a little bit, and then carries on to the other side. the next one that I come to is at 0. And I look at that exponent on there, it has an exponent of 1, so it just crosses right through. The next 0 I come to, I gotta make my way, gotta turn back up so I can get to -2, and I look at that exponent. That tells me it has a multiplicity of 2, so it's going to be tangent. It's going to hit that point and bounce back the same direction. So my sketch will look something like that. Once more, finding the zeros is my first step. So I have a 0 at +4. This one gives me a 0 at -2. And this one gives me a 0 at +2. My leading coefficient is negative, which tells me as it moved further right, it's going to go down. So now I know I have to get to here at 4. So I look at this exponent that's on that factor that gave me the 0 of 4. That tells me it needs to be tangent, so it's got to get there and bounce back the same direction. I know I have to turn back up at some point to get to this 0 at +2. So I look at the factor that gave me that 0 at +2, which is also an exponent of 2. So once again, it needs to hit there and bounce back down. And now at some point, I know I need to turn back up so I can get here to this 0 at -2. So I look at that exponent to get that multiplicity. It's a 3, which tells me it's got to twist through it. So it gets there, stays there a little bit, and then passes onto the other side. So that's what that sketch looks like. Here we are factoring these using sum or difference of cubes. When I use my sum or difference of cubes, I need to follow the pattern where it'll be A, B, A squared, AB, B squared. And the operators that will go in there follow the SOAP. So it'll be S for the same operator as what I started with, O for the opposite operator of what I started with, and AP, because this last one, it doesn't matter what the operator was, that last one will always be plus. So here I need to identify what my A value and what my B value are. My A value, I take what cubed would give me x cubed. So my A is going to be x, and my B, what cubed would give me 27y cubed. Well, 27 is 3 if it had been cubed, so that would be 3y. So following this pattern here, my first set is going to have what my A value is, which is x, and what my B value is, which is 3y. Between them is going to be the same operator as I started with. So I started with subtraction, so this one needs to be that same of subtraction. Then I have x squared, because it's my A squared, and then 3xy, and between those needs to be the opposite operator that I started with. Since I started with subtraction, this one needs to be the opposite of that, being addition. And last, I have b squared. When I square this 3y, I'm doing 3y times 3y, which gives me 9y squared. And between there, that's the AP, because it is always plus. It doesn't matter what I started with. So that is how x cubed minus 27y cubed would factor. On 11, my a value, if I take what cubed would give me 1? Well, if I cube 1, it gives me 1. My b value, 64, is if I had cubed 4. And I still have that n cubed, so it's 4n. So that's going to factor as 1 and 4n. And between those, it needs to be the same. I started with addition, so this needs to be addition. Then it's a squared, so 1. Then a times b, so 1 times 4n gives me 4n. And the operator needs to be the opposite of what I started with. Since I started with addition, the opposite of that is going to be subtraction. So I've got 1 minus 4n, and then b squared. So I do 4n times 4n, which gives me 16n squared, and that is always plus between those ones. For 13, 8 is if 2 had been squared. Now, x with a power of 6, well, that's if I had x squared that I had then cubed. So that would be 2x squared there. To figure out what the exponent will be on these that are not 3, but are multiples of that, divide it by 3, and that gives you what that exponent would be. My b value, 125, is if 5 had been cubed, and it has the y with it. So this first pairing is going to be 2x squared. Because it's addition here, it's going to be addition there. So 2x squared plus 5y. And then it'll be 4x to the power of 4, because when I do 2x squared times 2x squared, 2 times 2 gives me the 4, x squared times x squared gives me x power of 4. Then it needs to be the opposite sign that I started with, so minus, and then 2x squared times 5y to give me 10x squared y. And then plus 25y squared. Now, 14, 15, and 17, I don't know why it jumps to 17, but that's okay. These here, we're factoring by grouping. So when I group my first two together, and I look at those and I say, what is the greatest thing that they have in common? Well, both of those have 4x cubed that I can pull out. So I have 4x cubed, and if I do that, that leaves me with x minus 1. Then I look at this pairing. I have negative x plus 1. Both of those are divisible by negative 1, giving me x minus 1. One of my factors is what I pulled out from each of those. So one of the factors is 4x cubed minus 1. The other factor is what was remaining. I've got x minus 1 on both of those. So my other factor is x minus 1. Looking at 15, I group those two together. Both of those have in common an 8x cubed. If I factor that out, that leaves me with x plus 1. Here with the 27x plus 27, both of those have 27 in common, which leaves me with x plus 1. So one of the factors is what I pulled out, 8x cubed plus 27. The other factor is what I had remaining. X plus 1 was the same on both of those. But you must be able to identify that 8x cubed plus 27 is a sum of cubes. That would be if it had been 2x that had been cubed plus 3 that had been cubed. So fully factoring, doing my sum of cubes, which is what I just did up here, this is going to be two x plus 3, 4x squared minus 6x plus 9, and then x plus 1. You need to check and make sure that you have factored completely. 17, group these first two together. Both of those have in common an x squared, leaving me with 3x plus 1. Both of these, well, all they have in common is a 1. And already it's 3x plus 1, which is what I need this one to equal. So I can always factor out a 1, leaving me with 3x plus 1. So one of my factors is what I pulled out, x squared plus 1. The other factor is what was remaining, 3x plus 1. And that is as far as that one factors, because while, yes, these are both perfect squares, I'm adding between them, so it's not a difference of squares. Looking at 19, it wants me to give the increasing intervals. Increasing intervals are where, as I move from left to right, my graph is going up. So I am increasing from negative infinity, going until I get to this point here, and I only care about the x values, so negative infinity to negative 3. And then I increase again from here, going to there. So the x value of this point is negative 1.5 until I get to this x value of 0.5. And then I'm increasing one more time from here. And even though it looks like this flattens out, it doesn't. This is increasing the whole time there. So from 2 to infinity. It also wants me to give the maximum and minimums. So I have maximum points or high points at mountaintops. So I have negative 3, 0, and 0.5, 130. So these are maximums of the y value. So I have a maximum of 0 at x equals negative 3. I have a maximum of that y value, 130, at x equals 0.5. Minimums are at my valley. So that's a minimum of the lowest it goes down to, that y value, negative 1,400, at x equals negative 1.5. I have another minimum of that low point, that y value, negative 400, and it happens at x equals 2. 20 wants the decreasing intervals. Decreasing intervals are the other side of increasing. That's where I'm headed down. So I'm headed down from negative infinity until I get to this x value of 1. And also from here to there. So the x value is 1.9 until I get to this x value of 3. And also here all the way down. So from 3.7 going all the way to the right to positive infinity. My maximums are those two there. So I have a maximum of the high point, the y value, 2, at what that x value is, 1.9. I also have another maximum value of this y value of 1 at x equals 3.7. My minimums are those two. So it's a minimum of that low value is 0 at x equals 1, and another minimum also at 0 when x equals 3. 21 and 22, we are saying what the degree is. Okay, so the degree, when it's in factored form, I add all of my numbers up. So I have 3 plus 1 plus 2. So my degree is 6, which would be an even degree. I have a single root, so I'm looking, where do I have an exponent of 1? There, on this factor of x minus 4. So I have a single root at the x value that would make this equal 0 is positive 4. I have a double root at, well, here is where I have an exponent of 2. If I have x alone, that 0, that root is at 0. And I have a triple root, an exponent of 3 here on this factor, x plus 2, give me a triple root at negative 2. So our last question here, my degree, again, I add up all of my exponents. So I have 2 plus 3 plus 2, which that gives me 7. But I also have this x here. It doesn't have a number, but I need to know that that's 1. So my degree is 8 when I add all those up. So once again, it's even. I have a single root. The only place that I have an exponent of 1 is right there. So that's a single root at x equals 0. I have a double root. Well, I have one double root here when x would equal negative 1, and another double root here when x would equal 2. I have a triple root, or a multiplicity of 3, exponent of 3, right here. If I've got x plus 3, that would be when x equals negative 3.